All right. Okay. So, um, everybody said the majority of people said A. All right. Now y'all know a parallel port and a loopback port are different. Let me show you loopback plug. This is a loopback plug. These are loopback plugs. This is one for a fiber optic, and this is one for Ethernet. These are loopback plugs. All right. Loopback plug is it. Nope, nope, nope. You're right. So a loopback plug allows an output signal to be returned as input. Loopback plugs are used to test serial and parallel ports. Look at that. Used to test serial and parallel ports. A cable tester verifies that a network can carry a signal from one end to the other. A multimeter measures electrical properties such as voltages, amps, and resistance. An ammeter is an instrument that measures the flow of electric current in a circuit. Okay. So that would be amps. So ammeter is only looking at amps. Multimeter looks at voltages, amps, resistance, or what we call ohms. Cable testers, they're all about cables, loopback plugs for serial and parallel ports, as well as Ethernet ports. All right. Next question. You suspect that the power supply in your desktop PC is failing. You want to use a multimeter to test the power supply. Which multimeter settings should you use? You want to test the power supply to see if it's failing. You use ohms, watts, DC volts, or AC volts. And only choose one. Now let's use the process of elimination. If I want to test a power supply and I say a power supply converts AC to DC, which one of these should I eliminate? D, correct? I want to eliminate D. I'm going to eliminate A. So it's either going to be B or D. C, excuse me. And most of y'all chose C, so we're just going to go ahead and go with it. C is the correct answer. Ohms, a measure of resistance used to check the properties of a resistor. AC is a voltage input for a power supply. To measure the input, measure the power from the wall socket. So AC, wall socket. Multimeters measure amps, but do not measure watts. Okay, so next one. And a technician is troubleshooting a computer that does not start up correctly. Which of the following could the technician use to troubleshoot the computer? A three-prong parts retriever, a tone generator and probe, known good spares, loop back plug. Oh. All right, good majority of everybody's saying C. Here we go. Known good spares. So if we have a known good spare and we know it's working and we replace parts, then we can determine if the older parts or the parts in question are actually working. All right. Let's stop right here. So I'm going to X out of this right here. Save. Move on. All right. Let's move on. We've gone over the troubleshooting process already. So let's kind of go into the ticketing system. And just get some information about the ticketing system. Let's review some of the facts before we actually get into any videos or things like that. So I'm gonna go through all of the fact sheets and then tackle the videos, and then we can do like 4 questions. Then I'll leave the rest for you to complete. I'm gonna begin assigning assignments for you to complete starting tonight, tomorrow, and until we see each other on Monday. But you'll have enough time and enough opportunity to complete them. Please don't wait till the last minute to do so. Here we go. So we want to look at issue identification, issue management, issue resolution. Now, when we talked about the troubleshooting process, we talked about the 6th step, which is documenting. So we want to talk about how we go through the process of actually getting the ticket so that we can triage the issue and then begin the whole process to document all the stuff. We said we identify the problem, that we want to establish a theory of probable cause. After that, we're going to pick a theory and we're going to test that theory. From that theory, we're going to actually implement that theory, which is be step 4, test and implement. Then step 5 will be verifying full system functionality. And the last part, we're going to actually document the problem. But this is going to go through the process of what we do. Now, there's 2 types of help desk technicians. You have your specialists, support specialists. You have those that are call center specialists, and you have those that are actually going out to fix devices. In this case, this is what we're going to review. So we're going to go over user information, device information, and the problem description. The user information. If an individual reporting the issue via email, chat, or in person, you should record their name, and their contact information, the device, the model number, the network ID, the operating system, the warranty status, if applicable, and what is the problem. Then, in terms of issue management, who's going to handle it? The department a ticket should be assigned to. These are the categories of how you're actually going to issue or organize information. The security level of the ticket, whether it's low, medium, high. This will also determine whether it's going to go to a 2nd tier, a 3rd tier, or a manager. Okay. Each ticket will also include a place to record progress notes. And these notes are important for problem resolution. Now, in terms of the notes, they should be clear, concise, and include descriptions. This is what the description should be. If the fixes that have been tried, of the times that you have tried to fix the issue, research or follow-up conversations, next steps that need to be completed, and exactly how the problem was resolved. And then you have your resolution status, whether it's open, in progress, solved, or closed. Okay. Sometimes on my job, they will close it if you don't respond in enough time. They will close it. I've had some issues that in their ticketing system that have been open for a long time. Like it took them a year to give me a new phone, which was crazy. But anyway, let's kind of we'll go back into that. Not that yet. Oh, that's an actual lab. 2 labs. I was just trying to see if they had. That's more asset management. Let's just go into the video.
A ticketing system is a software application that's used to track help desk tickets. We use ticketing systems to identify and record technical issues, manage progress, and verify that those issues were fully resolved to the client's satisfaction. Depending on your organization's structure, you might hear about issues from a help desk call, a chat, or an email. You might even hear about an issue directly from an individual in a one-on-one conversation or meeting. You can also learn about the problem from your network monitoring and detection software. However it happens, you want to be sure to create a ticket. The first step in handling a new ticket is to record all relevant information in the ticketing system. When a user reports the issue via email, chat, or in person, you should record their name and contact information. Be sure to get as much information about the problem as you can. You want to be sure that other members of the IT team can understand exactly what's going on. Simply writing that the computer isn't working isn't sufficient. Explain exactly what happened. Is the computer powering on? Is there an error message? When did the problem start? Have any changes been made recently that could be creating the problem? The more relevant information you include, the better. Be sure to record information about the specific device that's experiencing the problem as well. If you're working with a customer who purchased the device from your organization, you'll probably want to record the model number, operating system, and warranty status. If you're working with an employee, you should record the device's network ID along with the operating system and the name of the software or peripheral involved. Once the IT department has received notice of an issue, the ticketing system is what helps smoothly manage the problem resolution progress. Issues are often organized by category. One of the most important categories is the ticket's severity level. This determines how time-sensitive a solution is. If a team is overwhelmed with open tickets, they'll need to know whether a ticket is high, medium, or low priority. This helps them prioritize their work. Another category could be the department that the ticket should be assigned to. For example, if you have a department that specializes in networking and another that specializes in applications, you'll want to assign the problems accordingly. You'll also want to include which tier a ticket should be assigned to, as most support teams have 2 or 3. The first tier is typically a triage tier. They collect customer information and perform basic troubleshooting. If it's a problem they can't solve, they escalate it to their second tier team. The second tier team is typically comprised of individuals with a bit more experience or who may have specialized training. If second tier support is unable to fix things or if they don't have the required permissions, they escalate it to the third tier. This tier is typically not customer facing. Instead, they solve issues behind the scenes and handle the most complex situations. Each ticket should also include a place to record progress notes. Your note should be clearly written and include a description of any fixes that you've attempted up to that point. You should include any information that you've gathered during your initial conversation with the user, during your research, or during any follow-up conversations you had. And be sure to provide information on any next steps and a detailed explanation of how you ended up resolving the issue, especially if it differed from your initial plan. You want to have a paper trail so that you can refer to the notes if you have a similar issue in the future. Once a problem has been resolved, it's okay to close the ticket. Your organization might have different terminology, but in general, tickets pass through open, in progress, solved, and closed stages. An open status indicates that a new ticket has been created and that the problem has not yet been addressed. An in progress status indicates that a ticket has been assigned and that an individual is working on resolving the issue. A solved status indicates that an issue has been fixed and is awaiting customer acknowledgement. And finally, once the customer verifies that their problem was resolved, you can move the issue to the closed status. And that's it for this lesson. In this lesson, we discussed ticketing systems. We discussed how we use them to identify, manage, and resolve issues that are reported to your department.
Ticketing systems are a crucial part of an IT department as they allow users to submit tickets for issues they may be having. Not only can this system be an efficient way to fix problems, but you can also use it to document the work you do in the IT department. In this demo, we're going to be using a software called Spiceworks. The help desk ticket system is just one of several options you can see on the list here. Now, there are 2 ways to create a ticket. The first is a tech who has access, creates one with this new ticket button here. This will bring up a menu to create the ticket. Our contact is the user having the problem, who happens to be Jack O'Neill. The related to field is designated for our equipment such as PCs, servers, and printers. Let's populate this with testout-PC1 since it's in our inventory list. The summary should give a generic overview of the issue, like PC won't turn on. Also, a description would be handy to give the tech who's looking at this more information, such as tried many attempts to turn PC on would be an example. Assigned to is the tech who's servicing this ticket request. Generally, this field won't be populated if the tech hasn't accepted the ticket yet, but since this is a tech-submitted ticket, we can populate it. If there were a due date, due time, or priority, you could populate these fields as well. Category, in this case, would be hardware. If there were screenshots or extra information to include, we could upload them as attachments with our submission. Click Save when finished. Now you can see the ticket is created and is listed in Open Tickets. We do have the ability to filter tickets by category, such as unassigned, open, closed, or even all. This could be helpful depending on how busy your environment is. Generally, users who submit tickets won't have access to view the ones in the help desk. For that reason, there's a user portal for them to submit their tickets from, and there's minimal work needed to set this up. Our portal address for the ticketing system is https://testout-server:9676/portal. I'm going to log out of the technician account so we can see what a user's view would look like. From here, the user can submit their email and click Login. If the user doesn't have an account created, they'll be prompted to provide more information. One cool thing is that Spiceworks does have the ability to sync with Microsoft Active Directory, so this could cut out an extra step for users. All they'd have to do is provide an email address. For the sake of this example, we'll input the user information. Janet Frazier is the user submitting the ticket. We could populate this with more information, but this will do for now. Let's click Save. Just like the previous ticket, we're able to populate the summary, such as with cannot open PDF, and a description such as whenever attempting to open a PDF, it doesn't do anything. If we had a screenshot, we could provide it here. Go ahead and submit the request. Now, let's go back to our Help Desk Tech Console. As you can see, we have several tickets created in our queue. If a ticket is in the accept state, that means it hasn't been assigned to a user, such as this one here. All the information pertaining to the selected ticket will be below. You can update notes on the ticket here. A nice thing is that there's a public response area where users can see the updates and also an internal note area that only help desk technicians who have access can see. This could be good for extra notes that might not pertain to the user, but could help solve the issue faster. Let's go ahead and put a response in for this broken keyboard that says, replace keyboard with new one. Select the checkbox, close the ticket, and click Save. This will automatically close the ticket and put a response on it at the same time. Now when we change our filter to closed tickets, we can see the ticket we just closed in there. It's always good to inform the user that you're closing a ticket before doing so to make sure their issues are actually resolved. That's it for this demo. In this demo, we showed you how to create a ticket and how to use the Spiceworks ticketing system.
All right, everybody, we're going to stop right here and take a 10-minute break and then come right back. Okay? 10-minute break and then we'll come right back.
Okay.
Okay.
Thank, In this lesson, we'll discuss some important pieces of documentation you might work with as a PC technician. Let's start by discussing policies and procedures. Policies are rules that have been set by an organization to address a particular problem or concern. A policy identifies the problem, why action is necessary, and what exactly should be done. Procedures define a desired outcome and then outline step by step how that outcome can be achieved, who should do the work, and when it should be complete. Many organizations have established standard operating procedures or SOPs that provide detailed information for performing complex business activities. Most SOPs involve activities that cross into multiple departments. An SOP usually includes the purpose and scope of the process, step-by-step instructions, and any equipment or software that's needed. It should also include common issues that may arise and a list of precautions or solutions. All industries are responsible for maintaining compliance. Depending on the industry, an organization may be accountable to city, state, and industry regulations. Because IT systems impact pretty much everything, end users and PC technicians should be familiar with any and all potentially relevant regulations. Splash screens are a great way to inform users about these specific regulatory compliance policies. As a PC technician, you should also be familiar with the details of your organization's security policy, which is just a document that provides information about overall network security. This could include something like a password policy. A password policy identifies password requirements on company-owned systems. These policies can specify how long a password needs to be, which character types are allowed, how many failed attempts a user has before being locked out, and how often a user needs to change their password before it expires. A backup policy outlines how often backups should be run, where they should be saved to, and how long they should be maintained. A physical security policy identifies who's permitted access to restricted areas and how that access is granted. For example, it could be through a key fob, a smart card, or a security guard. An acceptable use policy, or AUP, defines who has access to company resources and any restrictions that have been placed on the use of the internet or email. Similarly, a bring your own device, or BYOD policy, outlines rules for employees wishing to use their personal devices for work-related tasks. A BYOD policy usually indicates which types of devices can be used, information about any monitoring procedures, and details about which security features need to be enabled on the device. You should also be familiar with network documentation, like network diagrams and floor plans. A network diagram shows the location and IP addresses of servers, hubs, switches, and other network devices. It also shows the relationship between remote locations and the local links that connect to them. You may need to refer to the network diagram to determine the IP address that should be assigned to a new printer, for example. A floor plan provides the layout of all electrical, plumbing, HVAC, and wiring. This is a valuable reference when determining where you can safely lay cables and install devices without the risk of damage to the existing infrastructure. Another type of documentation you'll work with a lot is a knowledge base. A knowledge base is a web-based collection of articles related to frequently asked questions. The knowledge base is usually accessible by both the end users and the technicians and can be used to self-troubleshoot simple issues, such as resetting a password, finding a printer, setting up an out-of-office message, or changing your voicemail. As the technician, you'll probably find valuable information in the database as well. Sharing fixes and troubleshooting tips can help you save a lot of time and get users back on track faster. That's it for this lesson. In this lesson, we discussed various types of documentation, including policies, procedures, and network diagrams. We also discussed knowledge bases and how they can be used by users and technicians to troubleshoot common issues.
Okay. I made sure I wanted to highlight that video because the information in that video is very critical. Okay. The information in that video is going to kind of cross over both exams where you'll definitely have to understand policies and procedures, security policies, network documentation, and a number of different things. And you'll have to know the difference between what they are. What are policies? Rules set by the organization, and they're organized and they're aligned, as it says here, with the organization's mission. I don't know what's going on with my tongue today. Procedures, directions that outline step-by-step information on how something is to be done. Standard operating procedures. You will find out that you will go into many working environments and they have no standard operating procedures, and you will have probably be the one that will have to design some or make some for yourself so that you won't get yourself in trouble. As far as an SOP, they're carefully designed with a specific outcome in mind, and they include the following: the purpose and scope of the process, directions or steps needed to complete the process, required equipment, technologies, and supplies, common issues and solutions. And the reason why I bring this up, because when we get into networking, we're going to talk about access control lists. We're going to talk about password policies. We're going to talk about things that protect the network, in which we call them techniques, tactics, and practices. Techniques, tactics, and practices. So we'll be looking at hardware techniques, tactics, and practices, and we'll be looking at software techniques, tactics, and practices. And then these policies and these things that are associated with how we run business. People do not realize how important human resources is. Human resources run the entire organization. In some cases, you have issues with managers and you think you can run the human resources, you will find out quickly that you've just put yourself in the worst situation that you could possibly be in. Because then they will consider you a problem and they will try to get rid of you. I'm just talking from stuff that I know. I'm talking about me, but I'm just talking about people I've known that bucked against the organization and found themselves out there to have to find a new job. So, security policies. All right. Your password policy is very important. I want to explain something right up front. Your computer knows nothing about your username and password. Your computer does not understand what your username and password is. Looking for my whiteboard. Okay, here we go. The whiteboard. Only thing, you enter your username and password. You can enter in. Let me find. I just want to type. You will enter in. Let's say John, and your password may be 8_25. You enter that. When you enter that, your computer is looking for something that you refer to as a hash. And it could be a series of characters and numbers and things of that nature. That is what your computer understands. Your username and your password is a hash. So when you enter the correct username and password, you produce the same hash. If you change one character on that password, then now you create another hash. So it may end in 1. And your computer is going to say that's not the correct username and password because of the hash that you created. And in terms of a hash is a one-way algorithm. A hash is a one-way algorithm. I don't want the pen. Text. A hash. Now, I notice this is just information that I'm, bringing up. Let me change the font size to 36. A hash is a one-way algorithm. Okay? A one-way algorithm. It's hard to crack a one-way algorithm. All right? That's what a hash is. A hash is a one-way algorithm. So if this term comes up, this is why your password policy and things of that nature are so important. And as you advance in networking, these things are going to make more sense. Just hold that into your memory, put a pin in it. If you have making notes, put a pin in that note, circle it. You will come back to it at another time when we get more into security. Okay. Because we'll be talking about different types of hashing algorithms. And these are, we use these for verification, authentication. We verify individuals. We verify data with hash, especially in cyber forensics. You use a hash. If there's a crime that takes place, a computer crime or cyber crime that takes place, and you have to transport a computer, before you transport that computer, you'll make a hash or image of that system, and then that software will create what is called a hash. When you take that computer back to the lab to investigate it, then what should happen is you should produce the same hash. If the hash is different, then you'll know that someone tampered with the evidence. Okay, so we'll get into that content at a later time. Just make sure you put a pin in that. Something I wanted to share with you very briefly. And let's get back into this. All right. So a password policy. All right. Password policy. It does the same thing. Make sure your account should be disabled or locked out after a certain number of failed login attempts. Typically, it's 3. Users should, and that's to stop hacking, because when certain bots as well as certain individuals are trying to get access to information, you have that 3 times or 3 or 4 times, some a little more, with the opportunity to try to stop the hacker from gaining access to an account. Users should be required to change their passwords within a certain time frame. Some organizations, 30 days, maybe 60, 90, 180, 120, just depends on the organization. Users should, okay, a user should not reuse old passwords. You can block that, at least keep it like a year until a password is used again. Users must use strong passwords, not your child's name, not their birth dates, not words in a dictionary, because they're malware. That's called a dictionary attack or a brute force attack. And you can actually go through, there's software that goes through the dictionary and tries to crack the password just by entering dictionary terms. Personally identifiable information such as an employee's spouse name, child name, birth date, favorite. So all of y'all that got your child's name as your username and password, no, you shouldn't do it. Not Johnny 3535 14, or anything like that. Part of a username or email. Don't even use part of your username or email or anything like that. Password policies also contain information about password management, the rotation policies, the lockout threshold, how long you can be locked out. Is it a 10-minute? Is it 30 minutes? Is it an hour? Is it a day? As well as the password expiration. This is what a lot of people have issue with. Some organizations want you to use your personal devices. If I was running an IT business, I would not want you to use your personal device in mine. Show of hands in the chat room. We'll do it this way. If you have anti-malware on your cell phone, put a 1 in the chat. We got one person that has anti-malware on their cell phone. Okay. You have to be careful. You know what people like to do when they come to the school? Okay, here's another question. Put a 2 in the chat if you've updated the operating system on your laptop, computer, or tablet. A 2 in the chat. All right, so far we have 2 people, 3, that have updated their operating system. Okay. Now pay attention to these things. Here's the third one. Put a 3 in the chat if you have updated your drivers. If you don't know what a driver is, put a 0 in the chat. And don't feel embarrassed either. I will show you what your drivers are. Remember, drivers are software that controls hardware. The computer's brand new. Okay, cool. Drivers are software participants. I'm trying to let this person in. Your drivers are software that controls hardware. In other words, if I buy a mouse, purchase a mouse for my computer, and I plug the USB or the USB-C port into my computer will start to go on the internet and scour for the drivers. If you wanted to access your drivers on a Windows-based system, you right-click and you go to Device Manager. Y'all can see my screen, right? Because I don't see the green band around the screen. Okay, good. And then what will happen is you get a list of these drivers. Okay. If you have certain anti-malware software, if you have certain anti-malware software, what will happen is that you can get that malware software to update all your drivers. So it'll check through all your drivers, make sure it has the right settings. So this is software, like here's my audio interface, the Scarlett 6i6 USB. If I right click, I can update the driver, I can disable the driver, I can uninstall the driver, I can scan for hardware changes, or I can click properties and I can get this information right here. I can get the drop, showing y'all a lot of information. I can get the date, the driver. It has this date that 8, so you can see when I updated my computer the last time I had to do a clean install, because that's when I installed these drivers again. The driver version, you have your driver details. If you click there, you'll get the details of the driver, where it's located, where the driver folders and files are located. If you can update your driver, you can disable, you can uninstall. The rollback is if you have an issue with your computer and it's acting funny, then I could come in, I could roll back to the last time the driver was working good. So I can get rid of the previous update. Okay. You can get details, but you don't get that much information about it, and events that are taking place. Okay. So it's kind of like, log files. Um, there's more I'll go into. So if I click update the driver, I can either, if I have something on my computer, I can look for the file, or I can click here and it will search the internet very quickly. If it can't find it, or it says Windows has determined that the best drivers for this device is already installed, then I can look to see if there's a Windows update that's associated with that. And then I can come here, it says it's up to date. I can check for updates, see if there's anything to check, because sometimes your software updates have driver updates inside them. So when you update your operating system, those drivers get updated as well. But you have to do this on a regular basis. Okay. It depends on your system. One of my students from BCCC, he had a Mac, and he took the Mac to get repaired, and he was using an older operating system because he had everything set to where he needed it. He's a designer for a firm, so he designs software, things of that nature, and he was using older technology. When he gave it to them, they didn't save his information. So they fixed the computer and then they updated everything. So he had to go back and downgrade the computer. He had to put the older operating system on it, and when he got there, he realized um, all of his programs couldn't be used. So a good majority of them could not be used. So he had to just chuck it up and just re-upgrade his computer and try new things. So he had an older version of Photoshop. He had an older version of design software, which he could still use, but you know, people don't want to move to the subscription model. So like if you're a designer and you have software, nowadays, if you purchase software, you'll have to go to the subscription model. And no, people want to save money. They don't want to be spending money all the time. So that's just something that you can, always make sure you're updating your computer, because when you update your computers, now you have the latest virus signatures. And before we finish these classes, we will talk about, if you have any issues, how to resolve some of those issues. And we will get to that. Any questions? No questions? All right. This is my channel here, Sure Cyber, or Surety Cyber. I'll be having a lot of things here, updates, informations, things about certification exams, tips, tricks, things of that nature. Please make sure that you subscribe here, because there'll be a lot of content that'll be coming up here as well. But getting back to this, bring your own device. You have to be careful about using your personal device, because here's another thing that you don't realize. When you use your personal devices, now you're at the mercy of the company, because the company can subpoena your devices. So you always ask them to give you a device. don't use your personal cell phone or your personal computer, because now their information is on it and they can request to view or go through your device, especially if you like to look at things that you shouldn't be. Um, and they can actually review that. So always be careful. I'm not going to get into a long, drawn out story about what I was told when I worked in the school system. Backup policies. There are backup policies. There are types of backups to be completed. Who's permitted to access restricted areas where backups are stored. Remember, I told you the guy that got fired, the student, for going into areas he shouldn't be. How access is provided, a key fob, a smart card, how access is logged and monitored. There are physical securities where there's key fobs, where there's Kensington locks, doors, drawers where they should be locked, restricted areas within an organization. When you do penetration testing, sometimes there's physical penetration testing where you need to gain access into a building, gain access into a drawer, gain access into a wiring closet or network closet. You have your acceptable use policy. Most high school students defy this all the way, and sometimes we do it as well. When we sign this type of contract, we're saying that we're going to use that computer or that technology in the way that it was meant for that organization. And this will cover computer equipment, computer data storage, internet access, email. So if that organization tells you not to go on TikTok or not to go on certain websites and you do it anyway, you have violated your AUP. All right. And remember, I told you when you go on vacation, they're going to check your computer to see if this called an audit, and they're going to check it to see if you're actually upholding those policies. When it comes to user education and awareness policy, the employee must always be trained because they are our strongest force, as well as they're also the ones that can destroy a network. Here's some issues. Clicking on links in a phishing email. The school system has got hacked so many times because individuals clicked on a phishing email. The hospitals, Union Memorial Hospital in Baltimore caught ransomware, even University of Maryland, because sometimes people will go to websites that they shouldn't go to. Responding to social engineering attempts, someone posing to be a manager, someone acting like, oh, I need a document right now, not shredding documents and throwing them in the trash. That can cause problems. Okay. Downloading and installing unauthorized software, people taking their own devices and connecting to the network. And when they connect to the network, then they're downloading any and everything on that network. It says, does that also include their Wi-Fi? Sometimes it does. Yeah, you don't want to get on their Wi-Fi, but it's different. So, like the school system, when I worked for the school system, it's different. The students had their own network. Okay, it says, can you put the link to your channel? And I did. I'll do it again. There you go, right there. So that's some things that you would really think about when, you know, interacting on someone's network. But not only that, you don't want to take your device. Like, I would never want to use my laptop in certain environments because I wouldn't want viruses to get on my laptop. Okay. Especially, I just got my laptop too. I wouldn't want it to get messed up. So, clicking on links in a phishing email. Actually, if you've ever gotten one of those Walmart emails and there's a link, you don't click on the link. You just take your mouse and hover over the link, and then you look at the address. If Walmart sent you something, it should be from Walmart.com, not from Ryan at Gmail or anything like that. Crazy. So I don't even respond to those. Just like I don't respond to those calls. And even if I do answer, I don't talk because I know they're waiting. I let the tape roll, and then if it hangs up, it hangs up. And that could be you know, employee awareness is key to preventing these behaviors. and education, user education and awareness policies are paramount. Familiarize employees with the organization's security policy, provide contact information, identify general IT support if available, and describe suspicious activities that everyone needs to be aware of. And there has to be some type of technical procedures in place. Remember, I said techniques, tactics, and practices. These are the things that we're learning. TTP. You'll see that as you advance more. All right. Things that you should know about the network diagram. If you're going to be a part of the network, you should understand different devices such as hubs, switches, routers, firewalls. We will talk about that when we get to the networking chapter. What is called a wide area link or a WAN link, the relationship between remote locations and WAN links. We'll talk about that when we get there. And I will explain what a subnet is later on. Okay. A subnet is just basically, just to give you a quick definition, you have your whole network like a house, but then you also have subnetworks like a network in each room. So say like if I had a switch in each room, that switch would basically establish that if I have 4 rooms and I had 4 switches in each room, then now I have 4 different subnets, okay, or subnetworks, which also can be separated with routers as well. Just to give you a technical definition of a subnet. Subnet definition. I'm trying my best to prepare you for networking as much as I can. As you can see, it's a subnetwork. It says a part of a larger network, such as the internet. What is a subnet in simple terms? A subnet or subnetwork is a network inside a network. Subnets make networks more efficient. Through subnetting, network traffic can travel a shorter distance without passing through unnecessary routers to reach its destination. If I was to look for an image, here is an image of a subnet. This is one large network where you have a router and you have all these different devices. This is internal. And then you have the outside internet. But all these are separated into one subnet. I don't like that one that much. See, now we're starting to really get too deep. But here are, if you see this router here, and you'll see there's one network here, 2 PCs, 1 switch. Here's a second network here, 2 PCs, 1 switch. And everything, they can route traffic to all devices. Here's 1 PC, 1 switch, network 6. And then here's network 4 between here, separated with the switch. And then there's network 3. So you have 1, 2, 3, 4, 5. You have a number of different devices and networks. Okay. So just a quick overview for when we get into that section. So what is a subnet? It is a division of a network, all right, or a subset of a network, a part of a larger network such as the internet. All right. Let's get back here. And now let's kind of move to mobile devices, because I want to get out of the PC technician and we're going to get into mobile devices. All right. So a majority of you have read through the chapter as well. I believe it was chapter 9 in the CompTIA book. So we're going to look at a number of things. First, when we talk about mobile devices, the mobile devices such as laptops, let's look at the the CompTIA objectives first. So we're going to we'll get back to the terms in a minute. So one of the objectives is you're going to have 1-1, given a scenario, install and configure laptop hardware and components. So our components are going to be keyboards, keys, random access memory, which is RAM, hard disk drives, solid state drives, hard disk drives, solid state replacements, wireless cards, or what we call adapter cards or access cards. Um, we're also going to look at the different facts associated with laptops, but I really just right now want to get into the different objectives, and then we'll talk about the the content to be learned. Here's 1.2, compare and contrast the display components of mobile devices. And the reason I'm showing you this is because when you take the exam, you want to know what areas you're actually missing. And so as you see here, we're going to talk about the display components. What is a liquid crystal display? And the different types of liquid crystal displays. You have in-plane switching, twisted pneumatic, you have vertical alignment. Then you also have, as terms of display, you have organic light emitting diode. You have mobile display components, Wi-Fi antenna connector placements. Does anybody know where the Wi-Fi antenna is located on a laptop? Okay. So it's the screen. Yes, it's located in the bezel of the screen. Let me get a good image of a laptop. Laptop, not a laptop, a laptop. All right. So I'm gonna pull up this laptop right here. So in the bezel is the corners or the border around the monitor. The border around the monitor, your antenna will be located in there. And somewhere in this portion right here where my cursor is, it'll probably be screwed down. Okay. Somewhere in here in the bezel. All right. So your Wi-Fi antenna is actually in what we call the bezel of the laptop. All right. If we were to look at laptop displays, this would be the bezel. All right. That's what they call the border around the laptop. They call it a bezel. And we'll go over a lot of those terms as well. Your camera, definitely, it has cameras, it has microphone. Some laptops have touch screens. Some a lot of mobile cell phones, of course, is a mobile device. Have your touch screen and a digitizer, as well as an inverter. Now, inverter converts DC to AC. So in the monitor, that's why they said be careful about trying to change out monitors. You have to really have skill to do it, because when you try, the monitor converts AC, alternating current, direct current, DC to alternating current to actually produce the power to produce the images that we're going to look at in a laptop. So we're definitely going to go over these terms, and that's compare and contrast the display components of mobile devices. Okay. The next one, you'll have to know about power management as well. And this, even though we got terms, this is going to be on the 101 as well as the 102. Now, we're just going to focus on the 101 for right now, which says, given a scenario, install and configure laptop hardware and components. So we're going to look at the hardware device replacement. In other words, the battery. How do we replace the battery? Okay. Then, in terms of mobile devices, we're looking at, there's a number of terms we're going to go back to. We're looking at this objective. Given a scenario, set up and configure accessories and ports of mobile devices. So it's a lot of configuring, if you notice. So you have to know your components, okay? Connecting methods, universal serial bus, you got to know your ports and connectors. Lightning, serial interfaces, near field communications, which is what Samsung used to do. Now Apple does it as well, where you can take two devices, put them together, and you can transfer information. Some people don't like it. They feel like it's a privacy issue associated with it. You have Bluetooth hotspots, all right? Some accessories in terms of having to configure these accessories and ports. Touch pins, headsets, speakers, webcams, you definitely have to configure those. you'll have to know the difference between a docking station and a port replicator, which is crazy because nowadays they look exactly like each other. Docking stations aren't like they used to be when you have to clip them down to the pins as they sit connected to monitors, keyboards, and mouse. It's port replicators and docking stations look very similar today. And then your track pads and drawing pads. We'll get back to this part later in terms of compare and contrast common operating system types. Now, remember, the 1102 is going to be about operating systems and management of those operating systems, which is software. The first part, the 1101, is about hardware, troubleshooting hardware, understanding hardware and hardware components and what they do. So that's why I'm highlighting the objectives of the exam before we get into terms and terminology. Now, this CompTIA 1101 has the objective of, given a scenario, configure basic mobile device network connectivity and application support. So as you've seen, it's been configure, component. So we're really looking at hardware information. All right. So we're going to look at what is called the wireless generations, cellular and wireless information. So G stands for generations, not gigahertz, it's not gigabyte or anything like that. It's the generation of technology. If you're old as me, I still got everything recording, I hope. If you're old as me, you can remember a time when, when wireless first came into play. And then you really, around the 2000 era, you were able to get your chirp phone, we think of it like Boost now, but it was Nextel back then. So you got your Nextel phone and you thought you was something because you could chirp and send people messages, all right, over the network. Then in 3G, we got SMS text messaging, we got video. 4G, the video got more advanced. 5G, it's off the rockers now because you can download movies in 10 to 20 megabits per second, megabytes per second, gigabytes per second, I'm sorry. But that G stands for generation. So it's the different years and the different technology that's associated with those particular years. Like now we're in 5G. And you'll find out there never really was a 4G because every time you went a certain place, if you travel somewhere, it would drop back down to 3G. So it was 3G LTE, long-term evolution. So it was just technology that moved us to the next generation. So we'll talk about all of these things: location services, mobile device management, mobile device synchronization, and then here's another objective: compare and contrast common network configuration concepts such as virtual private networks or VPNs. So we'll get into that information as well. Mobile device security, we're going to talk about test PC Pro, given a scenario, install and configure laptop hardware and components. So security, biometrics, near field scanners. And when we talk about near field scanners, we're talking about like when you go to the grocery store and the near field scanner reads the barcode as you're scanning your products, or as you see someone in the aisle and they're scanning inventory. So that's near field communication scanners or near field scanners. Then the real coup de grace of it, troubleshooting. We're going to get into some of the concepts of troubleshooting and what this exam entails. Given a scenario, troubleshoot common issues with mobile devices. What happens when you have to deal with poor battery health, a swollen battery, a broken screen, improper charging, poor or no connectivity, liquid damage, overheating, a digitizer issues, which in most cases is going to be replaced or you have to calibrate, physical damage ports, malware or cursor drift, or a touch calibration. All right. So let's go back to the tippy top and go into, let me close this. Since we're in mobile devices, let's get into laptops. So before we get into like In Test Out Pro, should we have sections 11, 12? Because my Test Out goes up to section 7. That's all yours goes up to section? You don't have 12? Anybody else have that problem? Can you, I'm a drop share real quick. Share your screen if you can and let me see it. So let me stop share, give you the option to share. Give me advanced, all participants. All right. So you should be able to share now.
My hitting share screen.
Yeah.
You see it?
Yeah. I like the wallpaper.
Oh, appreciate it.
Um
So let me pull it up. I
yep.
can't see because of the thing. Okay, so
Okay.
that goes to 2.9.5, and then I just checked on the
You know why you can't see it? It is because I think I have to go in Canvas in because I think I have the information there, but I haven't made it available. So
okay, because that's why I was wondering why all this information. I was like, I've been going through it and I haven't seen it, so I was like, what's
okay.
going on?
Yeah, give me a moment. Let me make it available for everybody.
I appreciate it.
Resources. Thank you for letting me know that. All right. Let's go to mobile devices. I gotta make the area. I gotta make the module first. So module 12. Mobile devices, add. Give me a second. Let me go to the Pro. There we go. 12. Yeah. All right. Give me a second. It's gonna populate in a minute. I'm gonna tell you when to refresh. Oh, oh, oh. So which Joker you like the best? Suicide Squad
Ledger.
Joker. Ledger? Okay.
Yeah, Ledger's the best one.
Yeah, he is. He fit the role. I did like the Joker. A lot of people didn't like it. You know, I feel like it kind of went into his background. You know, I think what you call is a great actor. But a lot of people are like, oh, we don't like it. He wasn't good. But I think that's because people are so tied to Ledger.
Yeah.
They can't they can't see nobody else in the room. All right. Go back to modules. Let me check. Yep. And I'm gonna move 12 up. Make it available. Publish all items. And module. All right. Refresh your screen. Let me see if you can see it. All the way like beside where the web address is. Yep. Scroll now. There's 2 and there's 12. There's mobile devices.
Yep.
All right, good. Thanks for
Appreciate
letting
it.
me. No problem at all.
All right.
Stop share. Right here. All right, everybody. So now it's there. I'm gonna collapse this. And we will kind of jump back into, because I do want people to maximize test out to the fullest. So, yeah, she told me that you do have access because you used it before. I think you used your personal email. So you may have access to test out, but when you try to log into Canvas, and I think I may have to reset it. So if you could hang out with us after I go over this, and then I'll try to reset it so that you can have access. So let's get into I want to get into the first concept. Where am I? Right here. All right. So I want to get into the first concept of laptops and laptop facts. There's a lot of terminology that I want to cover in terms of what we call laptops. So laptops are portable devices, and we're going to go over those components. So when we speak of portable devices, they're easy to carry. They have a battery power. We can use them in many different places. Okay. Here are some of the things that we should be concerned with laptops. Laptops and notebooks. They're portable desktop systems. They have similar hardware and they run similar software. You have tablet PCs, which is a notebook. Remember, I told you if you try to run test out on the tablet, it's going to be hard to navigate. Unless I think it's a Surface. Because I had one student, his Surface worked really well with test out. You have touch screens. You can tap on the screens. You can drag objects. You can do different things with those PCs. Smartphones are very similar because they're just smaller. They have a lot of the same functions. And nowadays, your tablets and your cell phones can also operate in cellular as well. You have global positioning systems on them. And then now we have the introduction of Chromebooks. I do not like Chromebooks at all. Um, they just don't offer a lot of services, especially my daughter's Chromebook. I can't stand it. A Chromebook is a special version of a notebook computer that uses an internet browser as the operating system. And that's why I don't like it. Because some things I want on the computer, not on the internet. All applications can and must run inside of a browser. But that helps um, learners over the past couple of years because they've been using this format for a while, especially if they have like in the cloud and they're using Google Classroom and a number of different of the Google apps. Things we want to really be concerned with these components. A processor, the central processing unit, the brain of the system. Here it says processors built especially for laptops. So here's what I want to do. Going forward, I don't want to be the one um, monopolizing the time. I want us to be able to share information, read together, do different things, because then I feel like it gives you more real estate in the class. If I'm the only one talking, and then you're going to lose interest, and it happens a lot. So I'm gonna pass it off to have other people read. Don't be shy. Don't worry. If you hear me, I've been stuttering so much. So don't be afraid to read. You know, we just want to share information. Okay. So I'm gonna start it off with the processor. Processors built especially for laptop computers have lower power consumption. They require consumption requirements, and produce less heat than desktop processors. Here are some aspects to look at. On most systems, you can configure the processor to use a lower bus speed when running the battery power. Okay. Now you may say, what is bus speed? All right. So let's look at the heart and the brain. Okay. All the arteries and all the blood vessels, all the capillaries and all that stuff around the heart are larger around the heart so that blood can pump faster at the heart. And since the heart is so close to the brain, those blood vessels are actually larger than most other blood vessels and arteries on the body. Okay, so that blood can go faster and information can go faster to the brain. Okay, same thing is with those devices. So when we talk about bus speed, we're talking about the size of the cables or the connectors inside the motherboard. Let's take an image and a look at a motherboard. All right. We're going to look at the bottom of the motherboard, at the traces of the motherboard. Okay. An image. Let's see if we can find a modern motherboard, or at least one. All right. Let's look at this one. No, that's not good. Okay. This is perfect. All right. So you see the CPU right here? I'm pretty sure either right here or right here is RAM. I'm thinking it's right here. But if you look at the wires, how wide the wires are that are leading to the CPU, leading to the brain, the wires. So we refer to these wires as buses, large groups of wires that are connected. If this is the RAM chips, and these groups of wires are connected to the CPU. And this could be something else, maybe our input output devices as well. So that helps with information going to the CPU back and forth to RAM and the CPU, because they're of a certain size and the processor now has a lot of information leading to us. All right, let's look at it this way. This is the inner city, and these are all the roads that lead into the inner city with all the people coming to work and all doing different things. As these roads are wide enough, you can get more traffic to Baltimore City. Okay. So that's why you always see a lot of highway projects. So it's the same thing in theory with technology. If you have major organizations such as your RAM slot, then you have your maybe like your mayor's office, which will be right here, then information can flow faster due to how the highways, the width of the highways, like 695, you have 4 lanes. If you go down to 23, exit 23 off 695, then you'll have, in some cases, 4 lanes, which will come down to 2 into 1 as the more you get into the city. Okay. I should say 2 lanes. But anyway, in theory, that's what I'm referring to. And I hope that analogy makes sense. Um, Here it says many mobile processors use automatic throttling to turn off extra cores or reduce the processor speed to conserve energy. So, what are cores? Because I feel like I have to explain these things. CPUs have what are called cores, or CPU cores. Not no core standards. I'm glad I don't have to do that anymore. I got it. Ooh. All right. Images. Perfect. So this right here would be a dual core CPU, a quad core CPU. And cores are just areas that process information. If you run a program, that program could be thread in one particular core, or for speed's sake, you can thread in multiple cores to run a program faster and more efficiently. So the more cores you have, the more you're able to process information in an effective and faster manner. So this is just to describe this image right here. Let's see if I can make it larger for everybody. All right, here we go. So this is what a particular processor looks like. And here you have the graphics processor, and there are a lot of things that are now inside the processor. I hate when they do this stuff. Stop seeing this ad. Not interested. Anyway, we'll pull up. Bus, a group of wires or one wire that carries data from one place to another. Absolutely. Absolutely. So if you have, I'm just going to double back for a minute, everybody. Asus motherboard. Okay. Okay. So I click on this motherboard and I get hopefully they'll give me a flat image of the motherboard. Good. All right. And let's make it larger. All right. So if this is your CPU, here's your RAM slots right here. Okay. These RAM slots and the wires that lead to the CPU are going to be large. They call that a bus. Okay. The wires from a group of devices that lead to another, or the CPU. Here are your expansion slots right here, where you put your graphics cards, your TV tuners, your input output ports, like if you want to add another monitor or things of that nature. And if I'm confusing anybody, please stop me. So, Mr. Helton, I don't know what you're talking about. Can you break it down? Stop me so I can, give some more understanding. So here, all the wires that are connected to here leading to the CPU, we refer to them as a bus. Okay. If the memory that's going to be here is associated with this RAM, not RAM, I'm sorry, but the expansion card, then there's going to be a group of wires going back and forth. That is a bus. Okay. Um, uh, Wires are pathways that lead data and information to another area of the computer. All right. So that's what we mean by bus. All right. Processors do not have the large heat sink on mobile devices and fans to dissipate heat. So that's what a heat sink and fan is for. Let's show another image of a heat sink and fan. Just a basic heat sink and fan. I have this in my computer, but I just wanted to see a basic. There's a basic heat sink and fan. Okay. Right here. Perfect image. That's the heat sink right there. Looks like a radiator. We call this passive cooling. So your heat sink is for passive cooling. It draws heat away from the CPU. Then you have your fan that sits on top, the active cooling. Once this draws the heat away, the fan blows the heat up into the air to cool off the CPU. And this is the power connector for the fan. So the fan is an active cooling unit, and the heatsink is a passive cooling unit. Active, passive. Okay. And that's just a basic, regular heatsink and fan. Okay. Yep. The heatsink draws the heat away from the CPU, and the fan blows that heat up into the air. If it's a liquid cooling, and with liquid cooling, what happens is the liquid cooling unit rolls cold water over the CPU to pull the heat through it. Once that water gets hot, it dissipates, it goes out, and then goes through like a pumping station. That water is then cooled, and then it circles back over the CPU. So Once that cool water gets over the, or cool liquid, because it's not water, once that cool liquid goes over the CPU, it draws the heat away. Then it goes through a cooling unit, it's cooled off, and then it repeats the process over and over and over to keep the CPU cool. 10-4, good. Your laptop memory. Memory is different. We haven't covered memory, so I hate that we are introducing concepts that we haven't covered yet, and I have to explain them. So there are different types or different forms of what we call memory. All right. Let me pull up an Excel spreadsheet for a second, just so we can do this. All right. So in terms of memory, let me make this larger so everyone can see. All right. In memory, we have different types of memory. We have PC memory, we have laptop memory, and then we have like tablet slash mobile device or cell phone memory. Okay. So before we categorize those, we have PC memory is normally called DIMM, which stands for dual inline memory module. Okay. Sorry. LE module. So that's PC memory, dual inline memory module. Now I'm gonna go find a quick image. Give me a second of DIMM. All right, we're gonna use this chip right here. Uh, Images. Perfect. So that's a DIMM chip right there. All right. Let me get the snipping tool. I'll build these on the spot. All right. And we're going to paste. So this is a dual inline memory module. It's dual inline memory because on both sides, there are pins on both sides, hence the term dual. When you think of a SIM card, like in your cell phone, you only have the pins on one side. So SIM stands for single inline memory module, where this one is a dual inline memory module, just meaning that there are pins on both sides of the chip. Okay. That's what SIM stands for. So there are other different names for it. We refer to it also as RAM. We also refer to this as RAM, which stands for random access memory, just meaning it's temporary storage. So your PC has dual inline memory module, which is also RAM. And this is also interchangeable with these other devices as well, where the memory inside of them is considered RAM as well. Random access memory, meaning it's temporary storage. It's very volatile. If your system happens to stop working, what will happen is that you will lose all the information. Your operating system, your apps, your programs, everything is loaded onto this chip. And this chip refreshes, just like your eyes refresh. This chip refreshes with anything you do. As we're talking right now, the chip is refreshing very fast so that it can process information and help the CPU to process. Okay. So PCs use DIMM, or what we call dual inline memory modules. Okay. Laptops use something different, very similar, but different. It's called SODIMM. which is kind of crazy, the name, because it stands for um, single outline dual inline memory module. You're like, what's up with your typing, man? So laptop memory is SODIMM. Okay. You may also see a replacement name called UNIDIMM. UNIDIMM. All right. So UNIDIMM kind of replaces SODIMM, and you'll see it in tablets and some cell phones as well, just depending on that device. Um, and tablets, I would typically take UNIDIMM and put over here in the tablet section, because you can see it there as well. But they may have some type forms of SODIMM as well. Okay. And they look as follows. Is everybody following me? Is this making sense? I'm not losing anybody. SODIMM. As you can see, they're a bit smaller. Here are versions of SODIMM, or a SODIMM memory module. This is what a SODIMM would look like. And then to show you an image of UNIDIMM, and this is our UNIDIMM chips. UNIDIMM chips look very similar to SODIMM chips. So here's a SODIMM. If you look at this image here, here's a SODIMM chip, and here's a UNIDIMM chip. Okay, very similar. Okay. All right. So that's memory. So when we talk about SODIMM, UNIDIMM packages with synchronous dynamic RAM, we'll get into that concept later. But dynamic RAM is just another name for your DIMM chip. Dynamic RAM. So that's another name that is synonymous with RAM. Dynamic RAM, or dynamic random access memory. When you see synchronous, or SDRAM, synchronous dynamic RAM, that just talks about how the RAM works in tandem with the CPU. I mean, sort of like how the heart beats with the brain for the flow of blood. So, in the same instance, synchronous dynamic RAM means that your RAM is going to sync with the clock speed and the flow of data to the CPU. So, that's what that means. Does that make sense? Yes or no? Sorry, y'all. I didn't have the chat up, so I don't know if people were. I'm sorry. You're right. Small outline. I'm saying single. You're right. Small outline dual inline memory module. Thank you for the correction. Small outline. Yep. It's not single, it's small. Single inline is SIM. So cell phones would have what is called SIM chips. SIM or SIMM. Single small inline memory module. Okay. And here's an image of a SIM chip as well. Your typical SIM chips right here. Or SIM card. All right. Okay. So that's memory. And when we talk about DDR, DDR2, DDR3, and DDR4, we are referring to the actual speed of the device. The speed of the device. All right. And we're talking about the different generations and the different speeds of RAM. So DDR3 would be for older technologies. DDR2 would be RAM chips that are associated with older but more modern than DDR3. DDR. DDR3 is more modern than DDR2. I believe my computer has DDR4 RAM chips inside of it, and anything current right now in this current generation, can't remember if we're in generation 12 or 13, but it would probably be using DDR5 chips. Okay. Here it says many notebook computers come with a base amount of memory built onto the motherboard and 2 or more additional memory slots. When replacing notebook memory, make sure the size, speed, and the type of modules you purchase are supported by the system. Okay. Then we're going to look into a keyboard. These are just the components. A lot of computers, laptops have keyboards and access pads, or where you can scroll. It says keys such as the number pad and some function keys might not be on the keyboard, may or may not, but the functionality is accessible by pressing a special key to provide alternate functions for regular keys. It says you can use a USB port to connect an external keyboard, and some laptops include a PS2 port. I haven't seen them in a while. That's old, where you have the red and the green ports where you can connect your USB keyboard, where you can connect your keyboard and mouse. You have pointing devices on some laptops. You have pointing sticks, or which are the small knobs in the center of the keyboard. You have touching pads or touch pads. You have buttons below the keyboard to replace the mouse for clicks and right clicks and double clicks. You have your digitizer pad in the laptop and PDA systems to receive input, and you can connect the mouse. You also have video, where you have XGA screens. You have some screens with brighter viewing capabilities, and we'll get into a number of those. A lot of the laptops can be used for networking. You have internal storage, which is your M.2 and your NVMe chips or solid state drives. And port replicators are important nowadays because our computers are getting thinner and thinner and thinner, and because of flash technology, and you'll need a port replicator which will connect into like USB ports, USB-C ports, Thunderbolt ports, so that you can add additional connectivity to your computer. I just kind of wanted to go over those laptop facts before I actually went into this particular video here. So we're going to look at these terms: backlight, the light that illuminates the LCD screen; bezel, the plastic casing around the electronic device's screen; inverter, a power supply that converts DC from a computer to AC power; a port replicator, a device that connects several external devices such as a monitor, a mouse, and a keyboard. We're going to look at a liquid crystal display, and we're going to look at a light emitting diode. What is a LCD? An electronic display system that switches pixels on and off using liquid crystals that rotate polarized light. And then light emitting diode, a semiconductor device that emits light when an electric current passes through it. Okay. You may say that's a lot to learn, but I think you can do it. All right. Let's get into it. 5 minutes ain't bad.
Laptops are smaller, lighter, and more transportable versions of other computers. They're a large part of the portable electronics industry that also includes smartphones, tablets, and wearable devices. Laptops, like all portable electronics, come from several different manufacturers, utilize different operating systems, and offer differing feature sets. So, a laptop is just a portable, battery-powered computer with the same functionality as a desktop system. Besides their size, laptops have a few key differences from desktop computers you should understand as well. In this lesson, we'll discuss the different types of laptops, their similarities to desktop systems, and provide an overview of their components and connectivity. Laptops are designed for mobility. They're built small and resilient in order to withstand placement in backpacks, briefcases, purses, and other specially designed bags. Their components are made to withstand everyday wear and tear. They're also equipped with batteries and usually have external power supplies that charge when plugged in. Everything you need, including the screen, keyboard, pointing device, and storage, all come in a small package with varying screen sizes from 11 to 17 inches. For years, laptops were equipped with smaller versions of internal hard disks. The hard disks were made of a ceramic material coated with a magnetic medium. Data was written and read using heads that traveled back and forth to grab data from or put data on the rotating disks. Today, though, technology has advanced to a faster and more resilient type of storage called flash storage, which is available in different form factors. The two most common types you'll see are SSD and M.2. Flash storage is by far the most prevalent storage medium used in laptops. The first form factor, the solid-state drive, or SSD, is about the same size as a 2.5-inch hard disk, but with no moving parts. Newer systems use M.2, which offers its own advantages. Both SSD and M.2 provide superior performance to the rotational hard drive since they use memory directly rather than transferring data from magnetic heads. There's little to no latency. Also, they're smaller and produce less heat. Size is the most obvious difference between desktop and laptop computers. Desktops are made for expansion with built-in slots on the motherboard for things like high-end video cards and fiber optic Ethernet adapters. Laptops are designed for transportability and sacrifice some of that expandability. Components such as graphics cards, Ethernet ports, and sound systems are built directly onto the motherboard. There may be some expandability, but it's generally achieved with external components. Still, laptops can support wireless adapters, external monitors, and USB ports. Laptops are designed to utilize power more efficiently than their desktop counterparts. To achieve this efficiency, they're equipped with lower power-draining components. These include the CPU and RAM. They also use less power simply due to their smaller footprint. Other than size, the most significant difference between laptops and desktops is the battery. Most desktops get their power directly from the wall outlet. Laptops are powered by lithium-ion batteries. Other battery technologies were used in the past, such as nickel-cadmium and nickel-metal hydride, but these are no longer used due to various issues. Lithium-ion maintains constant power and lasts a long time. It's the same or similar to the technology used in electric cars. There have been a few issues with lithium-ion batteries exploding, but those issues have been addressed and aren't a major concern nowadays. Laptops often come with varying features. For example, the screen may be equipped with touch technology, allowing you to use a specialized stylus or possibly your finger to select objects or gestures to zoom in and out. You might also see laptops equipped with the ability to fold over completely or utilize a kickstand. Laptop models also utilize different operating systems. Chrome OS is based on Google Chrome and runs software inside the web browser. Laptops based on this OS are usually smaller and cost less than others. Mac OS is a proprietary operating system that runs on Apple-based laptops. Windows runs on laptops from many other vendors. It's the predominant OS out there and runs on all Intel-based laptops. That's it for this lesson. In this lesson, we learned some basics about laptops. Laptops aren't simply smaller versions of desktops. They're designed for users on the go who need the flexibility to take their computers with them. They're equipped with flash storage and operate on battery power, and they're developed by several organizations and vary greatly in their abilities, capabilities, and sizes. Their different operating systems provide functionality based on user needs. Knowing some of these basics will help you choose the best laptop for your situation.
All right. So now we want to get into the coup de grace, basically, the part that we should kind of, study, the different types of ports and things that's going to be associated with the laptop, the different ports and functions. So hopefully this one doesn't take that long. I really don't like showing videos that much, but this is a 5-minute video about ports and their function.
Most of the ports on a notebook are the same as on a desktop. A USB, RJ45, audio jack, HDMI, DisplayPort connectors look the same on both a notebook and a desktop. However, because of the proprietary nature of notebooks, there are some ports and functions that are specific to notebook systems. In this lesson, we're going to look at the different ports and functions that can be found on a notebook system. Before we begin, it's important to know that because of the proprietary nature of notebooks, the placement of ports or the presence of a particular function is different from system to system. However, understanding the basics of notebook systems will prepare you for working with any type of notebook you'll encounter. Here's a typical notebook computer. Let's start with the trackpad, which is below the keyboard. The trackpad is the notebook's mouse. It uses technology similar to a touch screen to detect finger movements and move the cursor. Most support gestures such as zoom in, zoom out, and switch pages. It also has a left and right button for left and right click actions. Some notebooks will have a toggle switch near the trackpad to enable or disable it. For example, if you plugged in a USB mouse, you'd probably want to disable the trackpad. Sometimes people forget to enable the trackpad after disabling it and will call you saying their trackpad isn't working. The first place to check if this happens is the trackpad on-off switch. One thing you might notice about the keyboard is that the F keys at the top have little icons. Keys on a notebook that have these icons actually perform two functions. When pressed by itself, the key will simply send the key's input to the operating system. If F1 or F2 is pressed, that input would go to the OS. However, notice this key down here labeled Fn. This is the notebook's function key. If we press a key while holding down the function key, the key will perform the secondary function, which is denoted by the icon. Some notebooks have function keys to control movie or audio playback. Some have function keys to eject CDs. Keyboards that have backlit keys will have function keys to control the brightness of the backlighting. Some notebooks have function keys to enable or disable specific integrated wireless devices, such as Bluetooth or GPS. Some have an airplane mode function key, which enables or disables all wireless functionality. The type of function keys really depends on the particular notebook. Above the keyboard is the power button. Also up here are the notebook speakers. Now, on this particular notebook, there's something above the LCD screen that I want to point out. This round lens up here is an integrated camera. Another thing you might find near the camera is a small round hole. This is usually the notebook's integrated microphone. This particular notebook has an LCD screen that simply folds down. However, some notebooks have special touch screens that can rotate 180 degrees, allowing the notebook to close and the screen to still be visible. Let's move to the left side of the notebook. On the left here is the notebook's DC power plug. This is where the notebook's power adapter plugs in to charge the battery and provide external power. The rest of these ports should be familiar to you. There's a VGA port, an HDMI port for connecting an external display, an RJ45 port for a network connection, and there's a mic in and headphone jack. Also on this side is one of the notebook's air vents here. This particular vent is where hot air is exhausted. Some of these vents are used to intake cool air, others exhaust hot air. Because of their compact nature, notebooks can get pretty hot, so it's extremely important to never cover up any of these air vents. It's also important to occasionally clean out these vents with compressed air, as they can get very dusty. On the front of the notebook is an SD card reader. This can be used to retrieve data from an SD card. Also on the front are some status LEDs. There's an HDD LED, caps lock, and number lock status LED, and there's an LED to show the status of the integrated wireless network card.
Some notebooks no longer offer Ethernet ports or RJ45 jacks. Instead, they rely solely on wireless networking. Most controls for Wi-Fi are integrated within the OS. You can turn the wireless networking adapter on and off, and you can also put the adapter into airplane mode when wireless communications are restricted.
On the other side of the notebooks are more USB ports, and this square port with a chain link icon. This is the notebook's lock slot and is used to physically secure the notebook to a location. It accepts a special cable lock with one end that locks to the notebook using a key. The other end of the cable is locked to a physical structure, such as a desk. Also on this side is the notebook's optical drive. Because optical drives are physically limited in how thin they can be, some notebooks forego having an optical drive in order to achieve a thinner design. Let's flip the notebook over and look at the bottom. At the top here is the notebook's battery. Some notebooks have integrated batteries that can't be interchanged. Other notebooks require the entire back plate to be removed to access the battery. This removable plate here is where the notebook's hard drive and memory are housed. If we wanted to upgrade the notebook's memory, increase the hard drive size, or even replace a mechanical drive with an SSD, we would do that here. So, those are some of the key features and ports that can be found on a notebook computer. As you can see, notebooks use a lot of the same connectors as a desktop computer. However, there are some differences with the function keys, hardware toggle switches, and ports like the cable lock slot. And remember, notebook function keys, port arrangement, and features are different from notebook to notebook. The information in this lesson is intended to give you an understanding of notebook basics, not a comprehensive look at every notebook type.
Okay. What I want to do is I want to kind of show you that if you have access to Canvas, now you can access this content on your own. Okay. So here are the laptop facts right here. If I click here, it's going to take me to the laptop facts it's going to load it, and then it's going to actually, if you have access in Canvas this way, so you can have access to these laptop facts here as well. This is some of the information that was just covered in the video. But it's good to know this information, especially when you're going to go to the question section of test out. Okay. So what we're going to do is I want to, even though we're kind of just cracking the surface of this section, even though we're just cracking the surface of this section, what I want us to do is as we migrated from laptop facts, now we're going to kind of get into aspects of understanding the function keys and what the symbols and the function keys actually do on a laptop. Some of you may say, is this going to be an exam? To some degree, yes, it's going to ask certain questions in regards to this. What the dual display looks like, what the wireless icon, wireless and cellular on, cellular off. Here's the Bluetooth icon, your GPS icon, whether it's in airplane mode or not. Your touchpad. I know it looks like a monitor, but here's the touchpad and the two right click, left click icons. Okay. Then here you have your screen orientation on your laptop, screen brightness to increase and decrease, your keyboard backlighting, your volume, whether you can mute, turn your volume settings down or up, and your media controls as well. So you will have to know those for the exam. This video right here goes into how to change a hard drive, which, I've had to do that a couple of times with my laptop, change hard drive, change the RAM. And the thing I like about it is that the videos kind of go through that. This video might be kind of long, so I may or may not play it. Oh, it's just 2 minutes. So I really...
Changing a notebook's internal storage device is quite a bit different from changing a desktop's internal storage device. For starters, most notebooks use thin 2.5-inch drives. Desktops, on the other hand, typically use the thicker 3.5-inch drives. In addition, rather than connecting individual cables, notebook drives typically slide into the drive bay where the power and SATA connections are made. Before working with any device, especially proprietary devices like notebooks, it's important to consult the documentation. Familiarize yourself with the features and specifications. This can help prevent a lot of problems, like purchasing the wrong type of storage device or not being able to find the location of a particular component. For example, although most notebooks use 2.5-inch internal storage devices, some very small form factor notebooks use 1.8-inch internal storage devices instead. After reading the documentation and powering off of the notebook, The first step in replacing the notebook internal storage device is locating the internal storage device bay. Many notebooks have a label or icon on one of the back or side panels that identifies where this is, but it's still a good idea to look at the documentation just to be sure. Once you identify the hard disk location, you typically need to remove screws to access it. Note that some notebooks don't have compartmentalized panels for different components. For example, MacBook Pro notebooks need to have the entire back panel removed in order to replace the internal storage device. On most notebooks, the internal storage device simply slides out. You'll notice that there are no cables that you need to worry about. Notebooks have stationary connections that line up with the internal storage device's connectors. This makes swapping out drives easy. Some notebooks use a caddy or other connected component that enables the internal storage device installation. Make sure to remove any required part and install it on the new drive. Seat the new drive in the notebook and ensure that it makes the required connections. Secure the new drive with any screws you removed. At this point, replacing the drive is now complete. That's it for this lesson. By reading a notebook's documentation and familiarizing yourself with the device, changing the internal storage is an easy task. When consulting the documentation, make sure to identify the type of internal storage device the notebook uses, find the location of the internal storage device bay, and complete all the steps required to replace the drive.
They shorten that video because that videos take like 15 minutes. Here's another video of installing laptop memory. Sometimes I wish we were face to face so that we could kind of walk through some of this on our own. But this is another video that's associated with installing laptop memory, and it just shows you the process of doing it. The reason I'm showing you these videos is because if you've never experienced it before, and when you begin to answer the questions, you want to have some type of mental mapping. So you're like, okay, I saw it's angled at a 45-degree angle, and once you depress it, it pops up, and I can pull the RAM chip out, or I can put the RAM chip back in when I replace it, and I have to push it down and make sure that it clicks into place. So when a performance-based question comes up, you already understand how the chips are actually supposed to be placed in, taken out, and removed from the system and replaced.
Most of your interaction with laptop notebooks is probably going to be replacing or upgrading the system's memory. Adding more memory to a notebook is probably the most cost-effective way to increase its performance. In this lesson, we're going to discuss how to upgrade the memory in a typical notebook system. Before you do anything, always consult the notebook's documentation. Notebooks are proprietary. Even notebooks by the same manufacturer can have entirely different hardware configurations and placements. When working with memory, it's very important that you install the correct speed and memory type. Again, use the documentation to determine this. It'll specify how many memory slots the notebook has and the maximum amount of memory that the notebook supports. With that in mind, let's look at what's involved when installing notebook memory. You should first remove the notebook's battery and any screws holding the panel where the memory slots are located. With that done, you'll be able to see the memory slots. You may find that one memory module is installed and there's space for one more. 2 slots is typical for most notebooks. In addition to a maximum amount of memory, notebooks also have a maximum amount of memory for each slot. For example, a notebook's maximum supported memory may be 32 gigabytes, but each slot only supports 16 gigabytes. This means that you can't buy a single 32 gigabyte small outline dual input memory module, or SODIMM, and install it. That won't work. Instead, you'd have to buy 2 16 gigabyte SODIMMs and install them individually. This brings up another important point. If the notebook supports dual-channel memory, as most do, you'll need to install paired memory to gain the benefits of dual-channel speeds. Most of the time, this means installing 2 new memory modules. Now, before you remove or install memory, always remember to place the notebook on an anti-static mat and wear an anti-static wristband. This is very important when working with memory, which is extremely susceptible to ESD, or electrostatic discharge. Before you can install any new memory, you might have to first remove the old memory module or modules. Most have 2 spring clips holding them in place. You release the memory modules by pushing up these 2 spring clips. When you do, the memory module will pop out, allowing you to remove it. To insert the new memory module, first line up the notch on the module with the notch on the slot. Then, at a bit of an angle, slide the memory module in until it bottoms out. While doing this, don't force the module down. Since the memory is keyed, if you're feeling a lot of resistance, you're probably using the wrong type. Assuming that it fits properly, press the module down until the two springs click, locking it into place. With the memory installed, you can put the cover back on and secure it with the screws. At this point, power on the notebook, enter the BIOS or UEFI, and verify that the memory you just installed is recognized and displays the correct amount. If the system didn't boot or only half the memory was recognized, the first thing you should do is make sure that all the memory modules are properly seated. If they are, you could then test them individually to see if one of them is faulty. You should also consult the documentation again to verify that the memory modules are supported by the notebook and that the memory size is supported as well. That's it for this lesson on how to remove and add memory to a notebook system. When installing memory, always be sure to check the documentation to identify the type, speed, and size of memory module that the notebook supports. And always make sure to use proper ESD protection when working with memory.
All right, so that kind of gives you a little more information into that. I'm gonna let y'all kind of watch the specifics of how to install a laptop. Let me see. That's for the hard drive. This one is for the keyboard. This one might be, no, they got her doing it, so it's a lot shorter. Yeah, I'll go ahead. Wait, 3 minutes. It's not bad.
All computer components eventually wear out, and the keyboard is no exception. Specific keys might stop working one by one, or the entire keyboard may stop. If this happens on a desktop computer, you can simply plug in a new USB keyboard. But with a laptop notebook computer, the replacement process is a bit more complex, and the process is slightly different depending on the laptop you have. In this video, I'll demonstrate how to replace a keyboard on a Dell Inspiron laptop. As we said, the process you follow will vary depending on your laptop's manufacturer and model. As such, it's important to consult your device's documentation before doing anything. The first step is to turn the laptop over and remove the battery. Next, remove the screws that secure the keyboard. Don't forget to replace the screws in a container so you don't lose them. Your new keyboard most likely won't come with screws, so you're going to need to install them. Next, flip the laptop back over and open it as wide as it'll go. Then, using a flathead screwdriver, unsnap the power button cover and gently lift it from right to left. Next, remove the screws at the top of the keyboard. Gently slide the keyboard up so that you don't damage the ribbon. Unlatch the keyboard connector latch and lift the ribbon. Okay, the old keyboard has been removed at this point. Let's see how to install the new one. Start by inserting the new keyboard's ribbon into the keyboard connector on the motherboard. Then press down on the latch. Insert the keyboard back into the palm rest, aligning it to the palm rest as you go. Screw in the screws at the top of the keyboard. Replace the power button cover by aligning it and gently snapping it back into place from left to right. Close the lid and turn the laptop over. Screw in the two screws from the back. Now you can insert the battery. The last step is to turn the notebook on and verify that the keyboard works. If the keyboard isn't recognized, the most likely cause is that the ribbon isn't seated properly. That's it for this lesson. While not as simple as replacing a desktop keyboard, replacing a laptop notebook keyboard can be relatively straightforward. Of course, that depends entirely on the type of notebook you're working on. Remember, notebooks are proprietary. For example, some require you to replace the keyboard through the back. This means that you'll have to remove the back panel, battery, motherboard, optical drive, and anything else that's covering the keyboard. By consulting the documentation and familiarizing yourself with your notebook, you should be able to replace the keyboard on most notebook systems.
the next one is going to be about replacing the hard drive. Okay, hard drive.
In this demonstration, we're going to discuss how to replace internal notebook components. We're going to look at how you get to some of the more commonly replaced pieces of a notebook system, such as the memory, the hard disk drive, the keyboard, and so on. Now, before we begin, please understand that every notebook is different. This isn't the same as desktop systems. With desktops, there's a fair amount of standardization between manufacturers, but that's not the case with notebooks. Before you attempt to perform any repairs on a notebook system, you need to go to the manufacturer's website and download the documentation. Most manufacturers provide some type of service manual. The service manual will provide you with the exact steps you need to follow to complete a particular procedure. Also, there are usually videos online that show you the steps for your particular system. There are a few best practices that we want you to be familiar with before you start just tearing into that notebook system. The first one is to make sure that you implement the appropriate ESD prevention procedures. For example, notice that this notebook system is on a static mat. I have my static wristband on, so we're not going to shock any of the components inside of it. Also, you'll notice that I have two pieces of tape on either side of the notebook. It looks really ugly, but it serves a very important purpose. Notice that I have this tape on the static mat upside down, so the sticky side is up. Why did I do that? Well, it's for storing the dozens of little screws that are going to come out of the system as we remove them. These screws will be all different sizes, and there will most likely be a lot of them. As we pull screws out, we're going to stick them onto the masking tape. If we wanted to, we could even write on the masking tape to help remind us of where they go. We could write hard drive mount, for example. Before we start taking anything apart, we need to unplug the computer from the power sources. We've unplugged the system, but there's one other thing we need to do to remove power, and that's to take the battery out. We're working with an old system, so it's easy to find. Sometimes it's not that easy, and the tech forgets about it. He or she disconnects the AC adapter from the system, but leaves the battery in. Okay, let's remove the battery. To do this, we'll slide the two battery connectors and take the battery out. Now I don't have to worry about this system being accidentally powered on while I'm working. The first thing we want to do is access the hard disk drive. In this system, it's located underneath, and the way you get it out is to remove the two screws. Let's go ahead and do that. Okay, the screws are removed. All I have to do now is pop this door out of its place. There we can see the hard disk drive. I checked the documentation, and it says that to remove the hard disk drive, I slide it in the indicated direction. Then I pull it up out of the slot. I have a little tool here called a spudger. It's kind of a weird name, but this is a very useful tool. It's good to keep a few around for moments just like these. They're made out of nylon, so they won't scratch anything, and they're non-conductive. You can use them like little mini pry bars. In this case, I'm going to use my spudger to pop this hard drive up and out so that I can remove it from the system. The next thing we want to look at is accessing the memory modules. I checked the documentation, so I know that this is the cover that the memory modules are located under. Next to the memory module cover, there's a little mark that actually looks like a small memory module. That's another indicator telling me where they're located. The documentation says I need to remove these three screws to access the memory. Then we have to pop the cover up. Like the hard disk cover, these screws are captive screws, meaning that they're stuck inside the cover. They can't come out. That's why we haven't put anything over here on our piece of tape. When we remove the cover, we have access to two different system components. The first one is our memory, as we talked about earlier. To remove a memory module, we have to spread the two little tabs on either end. If we do that, there's a little spring behind the memory module that pushes it up. As long as that memory module is flat, it won't come out of its slot. But as soon as it's elevated to about a 45-degree angle, it'll slide right out. At least that's how it works here. The same procedure is used to remove the bottom memory module as well. There's a second component that's also accessible underneath this door. It's your wireless network interface card. It's held in place with 2 screws, with one on each side of the card. These 2 wires are the leads that connect the wireless interface card to the wireless antenna. The location of the wireless antenna will vary from manufacturer to manufacturer. Most of them implement the wireless antenna around the display bezel. That makes a really nice big antenna so you get good reception, but some manufacturers put it somewhere else. In order to get the wireless network card out of this system, we have to remove these 2 screws and disconnect the 2 antenna leads. This is where the spudger comes in so handy. I can reach down and pop off that lead. This is one of those things that you need to document as you move along if it's not already listed in your service manual. You need to document which lead goes to which connector on this wireless network interface card. In this system, the black one is connected to the connector on the right, and the white one is connected to the left connector. You might actually want to write these things down, like the black lead was on the topmost connector. You could just take out your phone and snap a picture if you wanted. Let's go ahead and pop the white lead off with the spudger. Then we need to remove these 2 screws. Now, these screws aren't captive. They come all the way out, so we need to put them in a location where we'll remember what they came from. Let's put the topmost one over here on the right. That's why we put the tape down with the sticky side up. I'm not going to do it right now, just for the sake of time. But in the real world, I'd get a pen and write wireless card or something like that on the tape. I could even write it on a piece of paper and stick it on the tape as well. That way, when I reassemble, I know exactly where those 2 screws go. Notice that when I took the screws out, the wireless card popped up to about a 30-degree angle, kind of like the memory did. That allows me to remove it from the system. As you can see, this uses a mini PCI connector, which plugs into a mini PCI slot. So if I needed to replace the wireless network interface on this system, that's how I do it. The next component we're going to look at is the optical drive. The optical drive is on the side of this system. How do you get it out of here? Well, I checked the documentation. I found that the optical drive is held in by only 1 screw right here. If I remove this screw, the whole optical drive unit should slide out from the notebook. Let's give it a try. Once again, this isn't a captive screw. I put it in a new location on the tape. Again, in the real world, I'd also mark it so I know that it's the optical drive screw. When I do that, this whole unit should slide right out. There we go. This is our optical drive. If it were malfunctioning, I could slide a new one in and replace the screw. Okay, now let's look at the keyboard. In order to get the keyboard out, I have to remove the entire top cover. To do that, there are a whole series of screws that have to be removed. Quite a lot of them. You probably can't see this on the video, but each of these screws is identified with a certain code. It says F5. That tells me that I have to remove all of the screws labeled F5 in order to get the top cover off. So let's go ahead and do that now. My big screwdriver doesn't fit in these holes correctly. I've got a smaller one and I'll use it to remove these screws. This small screwdriver worked really well for getting into these small holes, but the one thing I don't like about this screwdriver is that it's not magnetized. Some of the screws are actually stuck down in these holes and I can't get them out easily. One option would be to flip the system over and try to catch all the screws as they fall, but I can guarantee you that if you do that, they'll fall into places where you can't find them, and you'll end up having to go find replacements. What I'm going to do now that they're loose is use my big screwdriver that does have a magnetized tip. I just insert it down into the holes and pull each individual screw out. We'll put them in a new location on my tape strip. I checked the documentation and found that in addition to all of the screws labeled F5, I also have to remove 3 other screws as well. These screws aren't labeled, which is why the documentation is so helpful. So I'm going to take these screws out. At this point, all the screws have been removed from the bottom side. We need to flip it over and open it up. We still can't get at the keyboard yet because there are still more screws that have to be removed. The documentation tells me that there's a strip running along the top of the keyboard that has to be removed before we can get at the keyboard itself. Again, according to the documentation, I can just put my spudger underneath it and push it up. Okay, I've got this strip off and I can remove it. Notice that this exposes 3 screws that hold the keyboard in. This is one of the reasons why it's so important to use a nylon spudger like this one. It gets pretty beat up as you work with various parts. That's a good thing. We want the spudger to be damaged, not the components we're working on. Because the spudger is softer, our components aren't going to get hurt. And these are a dime a dozen. When they break, you can just buy a new one. Let's go ahead and remove the 3 screws holding the keyboard in. At this point, the keyboard should just lift right up. We could take it out and replace it if we needed to. You'll notice that it's connected to the motherboard by a ribbon cable, so you'll need to get to the ribbon cable and gently remove the connector. There's a little locking piece that holds the ribbon cable in place. We remove it and put it in a special location so we don't lose it. I'll put it on my tape where I have the screws. Now the keyboard is off. If it were bad, I could replace it now with a new one. Notice that there are 5 more screws here labeled F5. In order to get this top cover off, we'd remove all these screws. The motherboard is implemented upside down. What you see here is the green bottom side of the motherboard. We haven't removed the CPU yet, as that would have required us to really do some dismantling to get to it. Typically, CPUs don't go bad too often, and you can find yourself with quite the project ahead of you if you have to replace one. Refer to the documentation to see if it's even feasible. Now, at this point, we then replace the defective components and start putting the system back together. The reassembly procedure is usually the reverse of the disassembly procedure. Your service manual may give you step-by-step instructions as to what to do to reassemble the system after you've replaced a defective component. A lot of times, though, it'll just say, reassembly is the reverse of disassembly. In other words, just go backwards through the disassembly steps to reassemble the system. That's it for this demonstration. In this demo, we talked about replacing internal notebook components. First, we talked about the importance of using the system documentation before we try to disassemble a notebook system. Then we looked at replacing common notebook components, such as the memory, the hard disk drive, the wireless card, and the keyboard.
All right, I know I videoed y'all to death. But yeah. And that's kind of some of the processes that you would take if you wanted to actually fix a laptop. So that kind of shows you how, if you have like an old laptop, you can go through and kind of work on it. What we're gonna do, I will be, since I do have things set up in Canvas, those of you that have issues like logging in, I want you to stay on with me. I'm going to dismiss everyone else. I know a lot of you are probably tired at this moment. If you have any questions, please, ask them now, or make sure you email me and I'll try to answer them the best I can. And for those of you that, I know Rose, you have, we're going to try to fix your situation as far as logging into Canvas and resetting everything. So, if there are no questions, I'm gonna go ahead and dismiss everyone. And please take a look at assignments will populate. You'll see dates start to populate where I want you to review and complete material. Okay. You'll see it in test out as well as you'll see it in Canvas where the assignments will begin to populate. All right.
Thank you. Have a good night.
Cool. Yeah. I'll make sure you have that. There's something due, not due today, but you will have stuff due from Thursday on. Okay. I'll leave a window for things to be completed. So check your inboxes because you'll see messages populate about the work that I want you to complete. Go ahead.
Okay, I'm still here.
Oh,
Royal.
Oh, I'm sorry. I just needed some advice on some, because I was looking at some different careers and something I might be interested in, and I saw that the UPS technicians, the something that drew in my interest, like something like hands-on technician, not necessarily like screen or dealing with the backdoor program writing, but more so like hands-on.
Okay.
Is that UPS? Like what kind of direction is that?
If you're at UPS, do you know what the position is? Maybe we can look it up.
It was
Can I answer that?
oh go
Go
ahead.
ahead. Go ahead.
It's more electrical engineering base.
Okay.
Ah,
Does have you do work in data centers, but more so setting up the the configurations for the UPS. So
Okay, all right.
is a lot of electrical, like AC
Okay.
DC. Because I worked on them. I worked on industrial side. I haven't really worked on the smaller ones, but I worked on very large ones. So it's heavy with electrical knowledge.
Okay,
okay.
electrical.
So you
Okay,
would
got
have to
it.
be like an electrician or something like that in order to handle
Correct.
that. Okay.
Well, I'm not an electrician, but
You were
I
trained.
yeah, they
Okay.
actually sent me to trainings with
Okay.
Snyder Electric, eight work on APCs,
Okay.
a lot of APC.
Okay. All right. Well, thank you. I appreciate it.
Yeah, no
Cool.
problem.
All
Cool.
right.
Cool. Cool.
All right, everybody have a good one.
All right.
All right.
Rose, hold on. Let me see if I can fix your login issue.
Okay, thank you.
All right. So let me go back to settings. My school. I haven't done it in so long. Students. All right. So go to Rose. Here we go. Hmm. View user profile. Do you know your username, Rose?
Um, no, I thought it was the email. No.
Yeah. I'm gonna directly chat you, and you can let me know if that's what you're. Do. Okay. Is that the username that you're using?
Yeah, that's what I thought it was. Yes.
Okay. So let me see about your password. I'm gonna give you a temporary password. Ready?
Yeah.
All right. So I'm gonna put it in the chat.
Okay.
The temporary password.
I think I got it. I saw it on the thing. Yeah.
Okay. Cool.
Okay. And
All right.
so then I just need to go in.
Yeah. See if you can log into test out with that temporary password, and then it should reset your password. Good night, Andre. You have a good one.
Oh,
Yes, I have you, Ryan. No problem.
okay. So hold on. Let me do this. Can because it's asking me to take the assessment.
What do you mean?
It's
Yeah. So you're in.
no, I'm not in. I apologize, I'm not in.
See, because
It's
everybody
saying
gone.
CompTIA. And it said, are you ready to take an assessment? Click start if you're ready.
I'm gonna stop my share. Can you share your screen?
Hello, is everybody still here?
Everybody's gone. Everybody's dismissed.
Oh, see, is class over?
Class is over.
Okay, good night.
Good night.
No.
Okay.
Yeah. So you should be able to share now.
Okay.
Are you prepared to take this assessment?
Yeah.
If you are ready. No, no, go to no. I want you to go to modules.
Okay.
Click on modules.
Okay.
And click on the course PC Pro Introduction. Click on that 1.1.1.
Okay.
Nope, down.
Oh, sorry. Okay. Hold on.
Click on 1.1.1.
Oh,
Yep.
okay. 1.1. Okay.
Yep. See if it'll kick you out. You're currently logged in. Launch. Yep. So you're gonna click OK, and you're gonna log back in.
Okay. Okay.
Your username and that temporary password.
Okay.
I'm shocked it didn't ask you to create another password.
I'm sorry, I have it written down.
Okay. Okay, good.
I wrote it down to have it. Hmm? Okay,
Good.
cool.
Good.
Okay, sir. Thank you so much. I appreciate it. I'll go
No
ahead and
problem.
reset this.
No problem at all. You have a good one.
You too. Thank you. Good night.
Good night.